when you have an integral and its bounds are set, that means if you have numbers on it. So if you have the integral of f of x from -2 to 7, what this means is you're finding the area under the curve from -2 to 7, right? If you have a function, -2's here, 7's here, axis is here, you're finding all of this from -2 to 7, all of this. How to find that, if you know what your function is you integrate it like normal, like we did before, but you plug in your 7 and your -2 to get your solution. So for example, if we're looking at the integral of 3x squared plus 4x from 0 to 3, what you do is you would integrate it, you add 1 to the exponent, you get 3x cubed over 3 plus 4x squared over 2. We can simplify this to x cubed plus 2x squared. Since we know our bounds, we're not going to add a plus c here, but what we have to do is we plug 3 into this function and we plug 0 into this function, and we subtract the 2. So the notation for this is you write your integral function, which is x cubed plus 2x squared, and you write 0 and 3. And what this means is you're going to plug in 3 and you're going to plug in 0. So when you're doing this, you start with the bigger number, which in this case is 3, and you plug it into your function. So we have 3 cubed plus 2 times 3 squared. And then minus, and you plug 0 in. So you get 0 plus 0. So we simplify this, we get 27 plus, what's this, 18? So you're going to end up with 45. And that's going to be your solution for this. So we'll look at a couple more. So we have 2 examples here. Go ahead, pause them, try them out. All right, cool. My turn. So we have our first one, x cubed plus 2x minus 8. If we integrate this, we'll end up with x to the 4th power over 4 plus 2x squared over 2 minus 8x. We can simplify this more. We'll get x 4 over 4 plus x squared minus 8x. And we're not done because we have to plug in our 7 and our 1. So I'll get rid of this equation for now, and we'll come up to the top right. We'll plug in our 7. We'll get 7 to the 4th power over 4 plus 7 squared minus 8 times 7 minus, and then you plug in 1. You get 1 over 4 minus 1 minus 8. I'm going to use a calculator to simplify this because 7 to the 4th is kind of outrageous. So you're going to end up with 2401 over 4 plus 49 minus 56 minus, and we can solve this parentheses, but we'll get -8 and 3/4. These two negatives are going to cancel out. We're going to get a plus. We're going to get 2401 over 4 plus 49 minus 56 plus 8 plus 3 over 4. If we combine our fractions, we're going to get 2404 over 4. But we can simplify these terms here, and we'll end up with 1. 2404, we can simplify to 601. So we have 601 plus 1, or 602. This example is kind of dumb. That's not me because we have the 7 to the 4. But the concept is the same, and you could use a calculator. Now for our second example, we have a cosine here. So when you integrate it, you're going to end up with sine x. And we have to plug in our pi and our 0. So we have sine pi minus sine of 0. So sine pi is 0 and sine of 0 is 0. So your integral of cosine x from 0 to pi is 0. This makes sense because the cosine graph looks like this, right? It goes down and then it goes up. Pi is right here. So it's up at +1 and then down at -1, so they cancel out and end up totaling 0. What else do I need for this section, bro? It's low-key it. I just gotta give more like practice problems. These are the last 2 practice problems that we got for this section. These ones are a little bit harder. Go ahead, pause it, try it out, try to figure it out. All right, let's go. So our first one, we have to integrate this, but how do you integrate a square root? The same way you derive a square root, you turn it into a exponent instead of a square root. So we have x to the 1/2 over here is the same thing, right? And this 1 over x to the 3rd, we could write it as x to the -3, right? And then we integrate it like usual. So we add 1 to the exponent. So we have x to the 3 over 2 over, and you divide it by this exponent here. So you get 3 over 2 minus, you do the same thing with this x on the right side. So you get x to the -2nd power over -2 because you're adding 1 to the exponent. We can simplify this more. I'm going to make this fraction, like better. If you're dividing something by a fraction, it's the same thing as multiplying it by the reciprocal, which means that we could write 2 over 3 and put this x on top over here. 3 over 2. And then this negative and this negative are going to cancel out. So we're going to have plus, and this negative exponent is we're going to have 1 over 2x squared. And now we could plug in our 4 and our 1. So if we plug in our 4, we're going to have 2 times 4 to the power of 3 over 2 over 3 plus 1 over 2 times 4 squared minus, and now we plug in our 1, we have 2 over 3 plus 1 over 2. Now we can start to simplify this out. 4 to the power of 3 over 2 is the same thing as the square root of 4 to the power of 3, which is 2 to the power of 3. So we can rewrite that as 8. So we have 2 times 8 over 3 plus 1 over 4 squared is 16. 16 times 2 is 32 minus 2 over 3. And let's distribute this minus to here as well. So we'll have minus 1 over 2. We're left with 16 over 3 plus 1 over 32 minus 2 over 3 minus 1 over 2. We can rewrite this 2 times 8 over here as 16. Then if we combine these fractions that we can, our 16 over 3 and our 2 over 3 will turn into 14 over 3 plus 1 over 32 minus 1 over 2. We have to find a greatest common factor of all of these, which we can multiply our 3 and our 32 to find it. We're going to end up with 96. So I'm going to use a calculator for this. We're going to end up with 448 over 96 plus 3 over 96 minus 48 over 96. And when we add that out and when we simplify it, we end up with 403 over 96, which I'm just plugging into a calculator is 4.197. So our integral for this is 4.197. When you have square roots or you have negative exponents, you treat them like you were doing derivatives and you just turn them into fractions and exponents. For this last problem, we're looking at 3 sine x dx. If you remember, when you're multiplying by a constant, you could just bring it to the outside and do it last. So that means that we have 3 integral from 0 to pi of sine x dx. So now you're just deriving sine x like normal, and if you remember, sine x turns into negative cosine x when derived, and we have to plug in our pi and our 0. And we keep the 3. So then that turns into 3 times negative cosine of pi minus negative cosine of 0. If you remember your cosine graph, cosine of pi is -1, but since we have negative cosine, it's negative 1, so it's going to be 1. Minus cosine 0 is 1, and it's negative cosine, so it's going to be -1, so it's going to be minus -1. So you're going to have 3 times 1 plus 1, or 3 times 2, or 6. So your integral for this function is going to be 6. So that's going to be it for definite integrals. It's just the opposite of a derivative. You do it backwards when you plug in the numbers. So we moving on.